In Pong 3, we looked at how to move the paddles, so we talked about delta time in particular, which is probably one of the most important concepts with love.update in order to actually get a functional game loop with behavior that depends on user input and AI. In this example, we're going to look at the ball, and the ball we're actually going to use random numbers to give it a random velocity, and we're going to explore game state a little bit as well. So this screenshot here kind of exemplifies the latter point, which is state. So far we've mentioned it a little bit, game state, and that just means that, whether the game is in the beginning where nobody's pressed any buttons and is sort of waiting for the first user input, whether we're playing the game and the ball is in motion, maybe the ball has gotten past one of the bounds and so player 1 scored and it's player 2 turn to serve. So then we go into the serve state, or maybe player 2 scored 10 points on player 1. And so now it's time to get into the game over state where the game is finished. In this case, we're just going to implement the start state. So it'll wait for user input to press enter, and then we'll go into the play state where the ball will sort of move independently. And in both of those states, we'll actually allow the paddles to move as well. Some important functions for Pong 4. So math.random seed is very important. So this essentially seeds the random number generator. So random numbers are not really random in the technical sense. They're what's called pseudo-random. So there's a function that uses some fancy math and ends up along a fairly normal distribution, calculates or creates some numbers that appear to us as random. But to the computer, they are very much not random. It's impossible actually to have just truly random numbers generated from a computer. You can use atmospheric noise and other ways to create much more actually random numbers. But even that's probably not technically random. But that feeds into math.random, the function down below. Now, the thing about what I just said is that if we use the random number generator without what's called seeding the random number generator, which means give it sort of an initial starting point that will make it different every time, then every time we run our game, because it's just an algorithm that's essentially calculating random numbers, it's going to actually be the same random numbers every single time, which means our application is going to run the exact same way, even though we're saying that we should have random numbers being generated. So math.random seed, we need to give that a number that is different every time we run our application. And to do that, we're going to use what's called os.time. So os.time is an interesting function because it gives us the time in seconds since basically 0000 UTC, January 1st, 1970. This is Unix epoch time. This is a very famous thing that had to do with the beginning of the Unix operating system, or its creation back in 1970. And this is a very large number. It's different every single time you run your application. It actually might be in milliseconds, actually. It might be in seconds. But it's a very big number, and it's different every single time that you run your application. A couple of other functions, math.min and math.max. So the former gives you just the smaller of two numbers, and the latter gives you the larger of two numbers. And this is important, as we're going to see, in clamping our paddles such that they don't actually go above the top of the screen and below the bottom of the screen, which was an issue that we realized that we had last time. So that is it for Pong 4's slides. I'm going to go over to my text editor here, and we're going to start implementing some of these features. So why don't we pluck off the first easier thing, which is making sure that the paddles don't actually go above and below the edges of the screen. Like I said, we can use math.min and math.max here to give us the lesser and greater of two numbers. Well, let's take going up as an example. So player 1 and player 2, if they're going up, I want to make sure that their y velocity, their y values rather, doesn't actually go above 0, so into the negatives. Because remember, everything is drawn relative to its top left corner. So if we make sure that y can't be any less than 0, well, then it won't go any less than the very top of the screen. So what we can do is we can say, give us math.max of 0 and player 1's y plus the negative paddle speed times delta time. And we can do that here as well if we say math.max for player 2 of 0 and the addition of negative paddle speed. If I run this just as a test, I need to also make sure that my clear is set to divided by 255, divided by 255, divided by 255, and divided by 255. If you see this in any Lua code that you're experiencing thus far, it's because the older version of Lua had regular RGB values, and the newer version has floating point values. So by dividing by 255, remember, you can stop that. So if I go up, and I'm trying to press up right now, I'm holding it down, and it's not going above the top edge of the screen, which means that it is clamping the y value to be no less than 0, which is what we want. And alternatively, we could do it for the left side as well, and we'll test that on the next iteration. So I'm going to go back up here, and we're going to do the opposite of math.max. So we're going to say math.min. So what we essentially want is for our y value to be no greater than the bottom of the screen minus the size of the paddle, which is 20 pixels. So I can say, give us the lesser of the virtual height minus 20 and player 1 with an added paddle speed times delta time. We'll do that down here as well. We'll say math.min of virtual height minus 20 and player 2's y plus paddle speed times delta time. If I save that and I run it and I try to go to the bottom, you'll see that again, I can't go to the bottom now, and the same behavior on the left side of the screen. The paddles are trying to move beyond the edges and they are indeed clamped. So we've successfully solved that issue. Now the next thing that I would like to get to is getting our ball moving sort of on its own. Now, so far what we've been doing is we've been waiting for user input, and such as when we are holding the keyboard down to a specific key, up, W, S, and down, then we essentially add paddle speed times delta time to our y value, negative or positive depending on the key. What we want to do is essentially decide on a velocity for our ball. And in Pong, it was actually common for the ball to have different velocities depending on how you sort of hit the ball, and also randomly. And this is where math.random ends up coming in. And remember, the very first thing that we need to do is actually seed our random number generator. So we do this with math.randomSeed. And again, we need a value to actually seed it. We need to actually give it a starting value upon which to base the random number generation. So to do that, we just give it os.time. Now this in and of itself isn't going to actually do anything. This really is tied to the use of math.random, which we're going to start using as well. So I'm going to give us some starting values here. So why don't we first of all decide on keeping some values for the ball's X and Y positions. So currently, I'm going to go to where the ball is being rendered, and we see here that we have some sort of hard-coded values. We have virtual width divided by 2, minus 2, and virtual height divided by 2, minus 2, which again shifts the ball a little bit up and to the left relative to the center of the screen, because the ball, remember, everything gets drawn relative to its top left corner. So what I'm going to do is I'm just going to delete this. I'm going to say ball X and ball Y, and we're going to define those ourselves. So we don't actually have those as variables yet. So what I'm going to say is ball X is going to be equal to virtual width divided by 2 minus 2, and ball Y is equal to virtual height divided by 2 minus 2. If I rerun this, it again looks like it's running exactly as it should. The ball is still being rendered right in the middle of the screen. Now, in addition to the X and the Y, we need a velocity. We need our ball to essentially update every frame and add some amount to the X and the Y, which is actually going to allow it to move across the screen, a velocity value, which we've been sort of setting ourselves with keyboard input on the paddles. And for this, we're going to set it here up above. So we'll say ball dx. D is short for delta of x. So we're going to say ball dx. And let's just say I want it to be random. Let's say maybe I want it to go left sometimes and right sometimes. And let's just say 100 pixels per second. So I want to choose randomly between one or the other. So what I can do is I can say math.random2. And what this is going to do is this is going to essentially flip a coin. So it's going to give us a value between 0 and 2 non-inclusive. And actually, no, I believe it's going to give us a value between, it's going to give us either 1 or 2. So what I can say is math.random2 is equal to 1. This is just going to be a coin flip at this point. It's just going to be 1 or the other. It could be 1, it could be 0 or 2. But what I'm going to do is I'm going to say math.random of 2 is equal to 1 and negative 100 or 100. Now this is a weird thing about Lua, because Lua, you might have been familiar or expecting me to use the ternary operator, which is this. So in C and JavaScript, you can do this thing called question mark something colon something, and it takes a Boolean expression at the very beginning. So what this will do is if this is equal to 1, this will be true, we'll get this value, and if this is false, we'll get this value. But in Lua, we actually don't have this syntax. We have and or. The way that it works is that and will essentially take whatever first false value it can find, or if not, the second value. And if it finds a false value, it's going to then calculate the or, so it'll have this or 100, and or operates in such that it takes the first truthy value that it finds, actually. So in that case, it'll take the 100. So by virtue of the way that those two logical operators work, the construction of and with or gives us a, in fact, ternary sort of functioning operator. So we'll do that. We'll say ball dx should be equal to negative 100 or 100, depending on this coin flip. And then for the ball dy, let's just say that I want it to be between -50 and 50. So that's essentially what that's going to do. So math.random can take in a single number, or it can take in two numbers, and it'll give you a value between that range. So between -50 and 50, we'll end up actually getting somewhere in that range. So you can assume then that the ball will either go up or sometimes it'll go down. And by combining a random x velocity of -100 or +100 with a negative y velocity, you can get all sorts of different angles upon which the ball will spawn at the beginning of the application's beginning. So in addition, remember, again, we're going into state as well. So what I need to do is create some sort of variable to keep track of the state. What I can do is I can say game state is equal to, let's just say start. Let's just say we're going to have two states in this application, start and play. So I'm going to do that. And then an update then is where we're going to have a little bit more work here. So let's just say if game state is equal to play, then the ball x is going to be equal to ball dx plus the time, or rather, sorry, ball x is going to be equal to ball x plus ball dx. And remember, again, we need to multiply by delta time such that the movement is interpolated across different frame rates. So we're going to do that. We're going to say ball x is equal to ball x plus ball dx times dt, and ball y is equal to ball y plus ball dy times dt. And remember, it can be adding either a positive or a negative number in this situation. Now, just as an illustration, just a test, let's go ahead and change this to play and run it. And we do indeed see the ball moving towards the bottom left of the screen. Now, if I rerun this, let's try that again. We see the ball moving towards the upper left. So in both situations, it got a dx of -100, the difference being that the ball dy was first some positive amount, let's maybe 30 or 20, and in the former amount, it was some lesser amount, like -10, -15, something like that. It could be more or less, I'm just ballparking it visually. So now let's go ahead and get back to actually creating two separate states. So what I want to do is I want to hit enter at the very beginning. I want to essentially have it be like it's waiting for me to press enter before it actually serves the ball. I'm going to go ahead and add something down here in the love.keyPressed function. Because remember, love.keyPressed will wait for one single key press as opposed to continuous input. So if I say else if, some auto formatting there, else if key is equal to enter, or key is equal to return, then, because return for Macs, because Macs actually their default value is return for the enter key, enter return. On Windows, it'll be enter. If it's the case that we pressed enter or return, I essentially want to say if game state is equal to, let's say, start, then game state is equal to play. And then else if game state is equal to play, then game state is equal to start. So this really doesn't do a whole lot in and of itself, but now we can essentially say up here, if because we have game state saying it's checking to see if it's equal to play, it'll actually not start the ball moving until we press enter the first time. So if I do this and then it's waiting, if I press enter, boom, the ball is moving towards the upper left. So that's great and everything. It would be nice if we have a little bit more visual input, and it would be nice too if I could restart the ball over and over again. So in order to do that, what I can do instead is in play, instead of just changing it back to start, I can do essentially what I did up here at the very beginning where I initialized the ball's values. I'll just say ball x and ball y and ball dx and ball dy get assigned back to their default values. So I'll do something like that. You might think that this might be a good place to put a function, so you could call this in multiple places and save a few lines of code. Totally could do that as well. So if I do this, if I hit enter, you'll see that the ball does get reset back to its initial starting point every time I press enter. Now, lastly, what I want to do is I want to reflect the state at the top of the screen such that it's very clear and apparent to me what I'm waiting to do. So I can do that here. I can say if game state is equal to start, then let's just indent this, not like that. Else if game state is equal to play, then, and then I want to change this to, we'll just say hello start state. And I'm just going to copy this and I'm going to say hello play state, just like that. And we'll do that. So now it says hello start state at the very top. If I press enter, it does say hello play state. If I press enter again, we go back to the start state. And then if I press enter, we go back to the play state there. So join me in the next section, Pong 5. We ended up adding quite a lot of features in this section. In the next section, we're going to do just a little bit of refactoring. We're going to dive a little bit into object-oriented programming, or OOP, as we start to break out some of all these variables that we have all over the place and put them together into some nice clean packages where we can represent, for example, the paddle as an object and the ball as another object. So see you again in Pong 5.